had a nice break. So we were on this lesson before we went to break, working on a cluster. So next lesson we are going to talk it's about scheduling. So the because it's not if you're very new to it, this is not like a usual way you do things. So we'll try to relate it to something that we actually would understand. So we have this restaurant example here. So Dania, when did you last visit popular restaurant?
Okay, probably last summer vacation.
Okay, that's yes. Then it's time that you take your family there at some point. So when you want to dine in a popular restaurant, there's something called making a reservation.
Yes.
Why is that? Do you think why that's needed?
If I need to dine in a popular restaurant, it is most wanted, and if I go without reservation, I need to wait for long. Sometimes I may not get a place. Correct. Even if I waited.
Yes, so that is the basic idea. So the HPC cluster is something like a restaurant. We could don't try to literally match all the components of the restaurant. Just understand the concept. There are a limited number of tables, and there are more users who want to dine. So if you have a reservation, then the restaurant can properly provision when people can come in. So they can give you a time, you go and sit there, but you have to tell the restaurant, I want to dine between 8 o'clock and 10. So the restaurant owner can plan things around it. The alternative is that you go and wait in a queue. So as tables become available, you can go in. So the queue is longer if you have more users, more people who want to dine than the number of restaurant tables. So in our cluster, we have a queue as well. It is not that because we like queues or like we like people to wait to show that we have something very good. So it's not that on purpose that people are made waiting. It's that because it's a shared resource, in order to provide everybody the best experience, we need to have some a software which is called a scheduler. So this is the scheduler person here, represented in blue. So because this is a software, for example, if Dania want to let in a friend, she can't do it because the software decides who sends first. So the software would consider how many people you are in your group, how long you're going to dine, and the load inside the restaurant. Then it will let you in. So we saw some words like this on our previous slide as well. So idle node, compute nodes. So these are the compute nodes that are waiting for you to come in and execute jobs. So the scheduler would send the people to this place. And then there are reserved nodes. So for example, for this course, we have a reservation for the course. Only course people can sit. So even though this table is free, the scheduler will not send everybody there. It will only send people who are in the course under the reservation. So most of the time you will find busy compute nodes. They are all the chairs or all the cores of the machine, all the memory of the machine are occupied. So nobody else can come in. So this means saturation. It's being used fully. You will also find mixed mode. That means some chairs are idle and some are busy. Some are allocated, which means somebody's on the way. You will most of the time, if you are not having exclusive access, for example, in Betsy, for example, or you will, especially on Saga nodes, you will be sharing your compute node with other users. So that you have to be a little mindful. But on highly parallel systems, you would have access to your own compute nodes mostly.
Yes. The queue manager here, this blue one, he or she has the overview of all the tables, which one are free and which one is reserved and all those things, right?
Yes, very good point. So the queue manager should have an understanding of what's inside, and also broken tables. The queue manager should also have understand broken tables, or that are being fixed. The things we see things like down or drain. So those things also need to be in the details that the queue manager should understand. Does that make sense, Dania?
Yeah. So the queue manager on HPC is not a person, right?
It's not a person, thankfully. Otherwise, it will be sort of biased. So it's a software. It uses many parameters to calculate your sitting arrangement. So it will not only calculate the existing load and also the load that you're going to execute. So if you ask to dine for a very short while, you will get a chance quickly. But if you ask for like days to sit there, then you have to wait for a longer time. So it always considers the overall benefit or the overall best experience, the quality of service, rather than like individual people. So it's a very fair system, in my opinion. In order to do that, Dania, what we in a computer system, what we do is we write everything that we need the HPC system to do in a file, in a plain text file, and give to the queue manager, and the queue manager will execute and give back our result. So this is slightly different than exactly mapping restaurant analogy to HPC. But this is the main difference between how we do things on a computer that have direct access and a computer that is behind a sort of a HPC setup. So for this, we need a terminal text editor. Everything you write should be on plain text. You can't open up graphical user interfaces and type text and save it and transfer it to the HPC system. It creates a lot of problems. One main thing you must learn is a terminal text editor. If you don't have a favorite one, you could use Nano. So I use Vim. What do you use, Dania?
I use Vim.
Yeah. So I might accidentally open up Vim because of my muscle memory at some point. Then you have to remind me that we are using Nano for the demo.
Yeah. A little recap would be, it is the same what we tried yesterday with scripting. Correct.
So if you are here, you already had exposed to these things. Okay, let's try to create some scripts, Daniel. So I'm going to create a directory because then if I log out accidentally, I can come back to this place again with today's date. mkdir is the command to make a directory, and I'm going to command cd to that directory. Then I will use the command print working directory, pwd. So I'm here. So here I'm going to create a small script. I will follow exactly what's here. So don't try to follow me while I do this. Just have a look to see the mistakes I make as well. Then in the exercise session, you could practice. So this is the script I'm going to create. There's a command called hostname that we have been using, which prints the name of the computer that we are on, the login node. For this one, we are going to use it. We use this script in order to print that instead of directly printing it, just to simulate a payload or something that you want to execute in a HPC system. So it doesn't matter what you call it, but for us, it's easier to call it with a .sh, so we will know that it's an executable file. First thing is to indicate which interpreter or which language that you are going to write. So I'm going to use the language bash. Dania, you could also write bash script in Python if you want, but bash is the one we sort of regularly use.
Yeah, I'm not used to Python script to run execute things.
Yes. So the command echo, it just echoes what we say. This script is running on hostname. So this will print the hostname, but through a script. So I'm going to use the Control O to save. I'll hold down the Control key and keyboard X key to get out. And to show you what I wrote, I'm going to use the cat command. So this is what we have. So what I'm going to do now is, Dania, that something I said don't do. So I'm going to do that for demonstrating purposes, and because it's a very small job. So I'm going to make this executable for Unix. If you try to run it now, example.job.sh, it will prevent job.sh dash. It will say permission denied. Because of security purpose, you have to explicitly say that it's executable. So these commands are there in the teaching material, and they will remain forever. Like, it's not like we're going to take down. There will be modifications, but it will be there, so you can try later.
Yeah, we
So
tried yesterday also this one, the same when we tried scripting. So just
very good.
It's a recap of it.
Very good. So I make it executable and run it again, and it prints that this script is like running on login 2. So this runs on the login node. It doesn't use HPC. It doesn't use queue manager. So why we should do this for big jobs, Tanya?
Because I will fill up the login node, so no, then it will be sluggish. Any other people cannot use it, and a lot of troubles to everyone.
Yes. So first thing that you need, now we are going to use it in you do the proper way, which is to summon the scheduler and ask the scheduler to do it for us. For this, you need a bank account. So do you have a bank account on Saga?
We have for the training, we have a credit card for this course. So
yes.
We can use that one.
Yes, for this we use CPU hours, not Norwegian krona. The way to find out which projects you have access to is the command projects. If you use the command projects, you can find it out. So you don't have to note down anything. It's there on the material, and when during the exercises, you could find that. Make sure you have access to 9970K, which is the name of
most of us will be having, will not have this much project access, because Sabri has access to many projects. That's why it's showing many credit cards or project accounts, I would say. If you are attending only this course and you don't have any access to any other course, or you will have only one, that is NN9970K.
Yes, thank you. I will show you the folder structure now. So we have this file, and instead of executing, I did this one before. Instead of doing that, I'm going to ask the scheduler to do this for me. The way I do is patch, and I will say I have an account, so you can charge from the account. So I'm going to do some mistakes. Dania, you have to point me out, because first time people will do this in exercise, they will do these mistakes. So I will do it instead, so they don't have to do it. So I will, but you have to be very cautious on what I type and help me.
Yeah. So here I can say now that your account is not right. You missed something.
Correct. And anything else?
What did I?
Yes. So I'm going to submit it with this wrong account name, and we'll see what happens. It says that invalid account partition combination, and this is one of the very frequent errors you get. So please double check and read the error. So it's very important when you use HPC systems. Later on, I'll show the log caser. Take a few minutes to read what it says before actually asking for help, because actually you are the person who can actually help yourself best if you can read these things. So this clearly means that it's there's a error. So I'm going to use this one, and now it is submitted, and I will ask SQ the command that we use to find out the status of my job, and it says pending. But is there a way that to make this faster, Dania?
You can, because we have this VIP reservation. So if you since we reserve for this course, you can say the job scheduler that you have a reservation, so it will make it fast.
make it faster. So I went to the restaurant, but I didn't say that I have a reservation. I just jumped in. But let's check one more time. So it's pending. So what I'll do is I will cancel that job. Yes, cancel. I will cancel it with the job ID. Yes, cancel job. Now I'll check again. The job is gone. I will make sure that it didn't create any log files, and I will remove that file as well. So the reason that it was long on the queue was that I didn't use this magic reservation. Partition equals cost. Does it look good now?
Yeah. No. Invalid partition. You should say name reservation. Reservation. Yeah, not the partition.
Like this.
I hope it works. Yeah.
Yes. So here, so we have some mistake there. So make sure that we write this very clearly, the mistake on the HackMD, the shared document, that people will use the correct partition.
Yeah. One question, Sabri.
Yeah.
Can you go a little bit up on the screen when you are seeing SQ? Okay, maybe you can do the SQ command again. I just have one question.
Yes. I will do that when I have enough time for when the job is pending. So now it's finished very quickly. So I didn't have time to look at it, the SQ. So it would have created a log file with the name of the job. Then I will use the command less to look inside. So this is a very important file that even if there's something failed, you should learn to read this. So it says about a job ID. If you want some help regarding this specific job, it's very important that you send us the username and this job ID. So it's easier for us to sort of find what's going on. And then this is the output. So if you remember, it runs on login-1 something. Now it's running actually on a GPU node. Sorry, not a GPU node, a compute node. So you could see that it's running on C137 and it consumes very little resources and some other details about this. So because this is a very short job, the statistics don't mean much, but it ran. So it actually executed on the login node. Sorry, the compute node. So I submitted from the login node. So next time, what I'm going to do is I'm going to submit something that could actually run for a while, so we can see what's going on there. Because I want to show how monitoring works. That might be something that you want to show as well.
Yeah.
So I'm going to use the Unix command called clear to get some space. I'm going to open up my example. So there's so I found it very easy to find out the progress with the command like date. It just prints what the current time is and date is. So I'm going to use that command here. Nano. So instead of host, let me type date, and I'm going to ask it to sleep for 60 seconds and print the date again. So the sleep command is, yes.
When you type the date, is it a Unix command that the computer knows that it should type the print the date?
Yes. So that is the. So I'm going to exit and I'll show you again. Control O, Control X. So this is the command. This is a Unix command. So it knows what it is. It's not something we write. So it will know what to do when it sees the command. So if you ask something to echo, okay, it will echo right away. But if you ask Unix to sleep 2 seconds before printing echo, it will wait 2 seconds and print it again. So that's the thing we are going to do. We're going to sort of simulate something that takes a minute and then execute. So I'm going to submit it again. the job that I submitted with this same reservation. Before I submit it, maybe I will remove this log file so it's easier to see the output. So I use my up arrow key to get the previous command, and it is submitted. Now I'm going to use the SQ command to find out what's going on. This is like asking the queue manager what's going on. So because we gave the instructions to queue manager and it went and executed a job for us, we always have to go through the queue manager to get information.
So the $sign with the user means the user you are. You can use your username instead of the $sign user, right, Sabri?
Yes, I can use this as well. Iterate, I will check the spellings of iteration. Iterate. So this means like every 5 seconds it's going to refresh, but I forgot the spellings. So now it has gone 56 seconds.
Yeah.
Now it's entered.
So can you explain something about what you see when you type SQ?
This tells you what's going on with your job, because when you give the instructions, when you write everything that you want to do and you give it to the queue manager, the queue manager decide what to do, whether you should keep it in the queue or go and run it, or was there an error, or there's a reason for waiting, all those things only the queue manager knows.
Yeah.
So we always ask from the queue manager, SQ, from the queue manager Slurm, you ask SQ for my use. If you use SQ without use, it will print a lot of things.
Yeah.
Give me details.
So that is a job ID, partition, name, user, and a ST. That is the status of the job. If it is R, it's running.
Correct.
PD. When we were not using the reservation, status was PD.
Pending.
So that is,
yes.
Okay.
So that's pending.
And node list is where your job is running, in which node, right?
Correct. Which compute node? Yes. So this could be more nodes because I didn't specify how many nodes. It ran on one node, on one core. It used the default values. So then our exercise is so we don't pay much attention to the payload here. That means like we are not actually running jobs here. We are just using a built-in Unix command to understand this scheduling process, or how to interact with this. So in a real case scenario, you will replace this date and sleep and other stuff with your scripts, your programs that you want to run. So the example, the exercise is about customizing, adding more things to this job. Before we go into the sort of more details about the exercise itself, I will show you one thing I did. So I have all this mentioned here: account, memory, and time, and etc. etc. You could also mention this inside the file. So the way you do it is example dot open the file, and before you write anything related to your payload or your analysis or loading software or anything, here you can instruct batch account equals NN9970K. So you see that Dania, this is like start with like a hash. Usually in Unix, it's a comment that's ignored. But here with hash with sbatch is a very special instruction to the queue manager. It will know what to do with it. It means that there's some instruction that it needs to get. So here we can also give a job name. New name. And then I will not use this sleep now because we don't. I don't want to waste more time on this. Running on personal. I'm going to save this, Control O, Control X, and I'll show you how the file looks like with the cat command. So instead of, I have something extra in this. So then when I submit the job, I don't have to specify accounts here, because accounts already mentioned here. So you could override it, but you don't have to. I could also mention memory and time inside this job. So I'll submit this job, and it'll submit SQ. Let's see whether it's finished or running. It's already finished because it's a very short job, and I use the reservation as well. So I have two Slurm files now, but I have to open the file with the correct ID. So this was the job ID 94593. So this was the log file for that. And it was running on C137. Let's see any questions regarding these things. Python based code. Okay. So let me see. How long do we have? We have until 11.
Yeah.
Oh, yeah. So there's a special request, whether you can use Python based program. So it's not something we prepared for, but I will see whether what I can do. I'll remove all the log files. So I use some other editor for that. Then I can use. So later on we'll learn about modules. So then you use now I'm using the system Python itself. So if it is a Python job, what we'll do is I'll include this in the example. I'm too lazy to type it again, so I'm using this double angle brackets yesterday we learned to take it inside. Then this output is from Python. So I could have actually avoided Python if I mentioned on the top of the Python file env, which env to use. So this is a Python script, Control O, Control X, and I'll show you again how it looks like. So the Python testpy is the command. So I will run that dispatch command again with the reservation for 1 minute and 1 gigabytes of memory. Ask the SQ command to see the status. I'll use my username directly instead of dollar again. So it's done. There will be a log file. I will see the log file. They need to say this output is from Python, and it's printed from Python. I only used very simple, not even any real Python, but it is printing. It's a print command. So you could replace that with a real Python script. Yes. Yeah.
And Sabri, since we have a bit more time, can we have a bit more discussion about this job scheduler?
Yes. So for the dope scheduler, what I'm going to demonstrate before I do the exercise is to show you this importance of resource binding. This comes after the resource request section, after the exercise, but I will skip the exercise now. I'll explain the exercise at the end.
Yeah. Before that, we are saying about the job scheduler. Does he or she, also the software it has a name.
Yes, it's Slurm that we use Slurm. So other operating or the other clusters, they might have different, but these days most popular one is Slurm actually. And
the sbatch command you were typing inside your job script and also on your terminal is some commands Slurm understands, right?
Correct. So you could actually go to the band pages, Slurm sbatch, for example. If you search for that, the best place is this shidmed.com place that where these people host it. You can get a lot of information about things that you can use with this. You could also use the man command on the terminal, but this might be easier to read. So when you also communicating with the scheduler, we should say that how long we want to run. So I'll run one example of this binding resources. So I'm going to open up this example job file, and I will also include more things like the time. I'll say I want to run this for 1 minute. Then the way you specify time is days. If you have 2 days and 10 hours and 1 minute, you specify like this. The minutes with the separate with the colon, and the days separate with the dash.
What happens if I specify a lot of time?
If you specify a lot of time, what the scheduler will understand is this person is like a heavy eater, it will consume a lot of restaurant resources. The chefs would be busy for a long time providing this person, and this chair would not be available for a long time. Then the scheduler make this person wait. If you go in, there will be more people waiting to dine. If you want a lot of time, it will fit in a slot where there's not busy. For example, maybe you have to wait in a queue, and it will let in that plus person during midnight, or some when the cluster is not busy. So if you ask more time, you have to stay longer. So you have to ask the optimal time. So after submitting this job, we'll talk a little bit more about it.
Yeah.
So then what else do we need to mention, ma'am? I'll also mention that I will need only one did I mention account, job, time, memory, and then you can also ask how many processors cores that you want. This is default is one. I will mention one here as well. These things, there are links, and I'll show you how to get more details, and we'll also talk about it in the rest of the lesson. So I'm going to use that date command again. And I'm going to ask you to sleep for 30 seconds. Print the time again. Sleep 30 more seconds. And date again. And I told the scheduler that I'm going to eat, I'm going to run the job. And now I'm just thinking about the restaurant because it's the lunchtime, it's nearing up. So I told that I'm going to only wait for 1 minute, and I'm asking that I'm already waited 1 minute here, and I'm asking again, okay, sleep more, sleep 60 seconds more, and print it. So I told the scheduler, I'm going to tell the scheduler, I'm going to wait I want only 1 minute, and I'm going to stay there for 2 minutes. Let's see what happens. Control O, Control X. Again, the file, how it looks like for you to see. So it's all the bash, the shebang we call it. It's a bash script. I included all the details about the accounts and time and everything inside the job itself. And I'm going to simulate that I'm going to run a job for 2 minutes, but ask only 1 minute from the scheduler. Yes, batch, because now I included everything in the script itself. I don't have to mention anything for the script, SBatch command. So the Slurm or the scheduler, it will come. So then you see that when I submit it, Dania, so you're supposed to find the typos in my script. So what happens when you submit is there's an error because I misspelled something. Do you see which part I misspelled?
End task?
Yes.
Because you missed some S. It shows, like I don't really need to look into this. The error message shows me that something is wrong here in end task.
Very good point. It's just you have to sit back and read a little bit. The reason I included this is to show this error as well. So when you have end task equal 1, I have used end task, but the correct command is end tasks with S. Oh, I used the wrong. Sorry, I opened with Vim, but it doesn't make any difference. End tasks, task. Is it correct now?
Should be. Just
yeah, we'll submit again. Yeah, ask. Now it's good. So so I'm going to wait. So now it's pending. Why is it pending, Dania?
Did you put the reservation?
I didn't. So I will cancel this. Cancel the job. Remove the log file and open it up again. So sorry, I should use Vim. I should use Nano. So what was the reservation name?
Course.
Course. I forgot to include this one. Reservation course.
I want to mention in real case scenario, you when you try something on your project, you may not have the reservation. So for this course, we don't want to wait for long. That's we created a reservation to run the job on time.
This is a trick so that we don't have to. Did I spell it correctly?
Yeah, I think so. If not, it will show you.
Yes. S batch example. Yeah, it's now there. So let's see now it's the SQ internet. It's running already. So the first 5 minutes, seconds, okay. So what was that? I promised that we talk, Dania, while it is completing. You told me something, I forgot.
Okay. I forgot. I was thinking about talking about Slum a little bit more, the job schedule, but you mentioned it, that Slum and the man pages and all. And one thing would be nice to mention, there are other job schedulers in other countries, national HPC or any other organizations, high-performance computing, they might use different job scheduler. But the principle will be same, but the commands like SBatch may be different if you're using other job scheduler in your cluster.
Okay.
Does Fox use Slurm or?
Yes, Slurm. Yes, we use Slurm. And most of the schedulers, clusters, they use Slurm these days. So now it's 1 minute up and 1 minute 5 seconds is up and still running. It didn't throw you out. 10 up, it's still running. 14, yeah. So we only ask for 1 minute and it's been generous now. It's waiting for a while. It didn't just throw us out. But now it's gone. Now it's very important that we read the log file. So I'm going to open the log file. So it started and it printed the first date, the first, the date command when it started. After 30 seconds, it started. But during the sleeping of the second 60 seconds, what it was, it canceled the job. It throw you out because due to time limit. This is a very frequent error message that we face. And usually when people contact us, they say, it just died. But this message clearly tells you didn't ask enough time. So you have to ask more time. So the queue manager throw you out because you stayed longer than you intended. You promised that you'd be inside. And the hours that you used analyzing your code, that the amount you paid will not be reimbursed either. So you lost that. But if you ask more time and finish early, the rest of the hours will be reimbursed. So you have to find out the optimal hours need, and that is one of the main lessons we have on our advanced course. So Dania, I'll explain the exercises now.
Yeah.
So what you should do is first try to create the example job, as we have done here, try to run it. And the specific part of the example is, as you can see, this file called slurm. You can customize the name of it. So you have to find out using the man pages and also the slurm internet pages, that how you would use a different name for this. Instead of using a default name, how to use a different name, and also send the errors and the outputs into different files. So here it's every errors and output, everything goes into one file. But the exercise is to see whether you can find out, you can do it so that it'll end up in 2 files. You don't have to exactly follow this. If you want to try something else with something that you are very concerned with, you could also try that. Main sort of aim of this exercise is that for you to create your first batch script and submit and read the log files and read the errors and be able to communicate with the Slurm manager. Is that clear enough, Dania?
I guess so. It's clear to me, and I assume that people will be able to do this. So on the schedule, we have 30 minutes exercise for this. And if you are done with something, you can try out with more jobs.
Yes, you can try out and ask questions. Dania, do you think we'll go for the exercise, or do you need a break now?
How about we go for an exercise so that everything we talked about is in our immediate memory. And then after we run a job and we get a little relaxed, have a long break, like 15 minutes. Is that a good idea?
Okay, Dania. And please update that in the scheduler.
Yeah, we will come back here at 11, 20 minutes past 11. And then
do the
we'll
exercise.
Go for a break. Yeah.
Yeah. And please use actively this hackability to ask things. Ask whatever you want. You don't need to mention your name or anything. Just ask, but be polite and use good language. But please do ask. See you in 20 minutes.
Yeah. Welcome back. I hope you had a refreshing break. How about you, Sabri?
Yes. Good. Yeah. So according to the schedule, Dania, that you should start the transferring files section at 11:45. That is 10 minutes. So small recap about the exercise. So the way for the specific exercise is to use this dash output, as we did with if you remember the sbatch commands we use. We use account, job name, for example, and then the output is appended with this %J. That means the job ID. So when the file is created, it will append the job ID to the output file as well. So usually when we write output files and also the error files, we try to make it connected to the job. The reason is that, let's say if you avoid this one, if you call it output.txt, without this %j, if you run the script several times, the file will be overwritten. So by including the %j sign, that you make sure that each job would end up writing its own output. So that is the thing that explained here. And apart from that, I see that all the questions have been answered on the shared doc. Let's see. So you have to make sure that the typos, to avoid typos, for example, this angle bracket is used in the example here, which means that is something that you should replace with a real value. Where else here? Yes. So you don't use the angle bracket project name, means you have to replace the entire thing with something real as you did. So you should keep the angle brackets.
Yeah, a good thing about making mistake is you learn it, then you will never forget.
Yes. Now what we do is, Dania, I would recommend that you even Bentham take over the screen and start slowly. So you can get 5 minutes extra.
Yeah, that we can do. And Sabri, thank you so much for taking most of the things for today and explaining it very well. I hope everyone, and I hope you got motivated with a lot of questions, and I know that you like to have more questions.